work now. Okay, cool. How many of you attended or watched the keynote today? Show of hands. 1, 2, 3, 4, 5. Okay, cool. No worries. Today I'll be giving you a rundown about what was announced in the keynote today. I was there in the SAP Center, and I think the energy was magical. There were a lot of fun demos. Jensen was, as usual, amazing. But let's get started with GTC. What is GTC? GTC is GPU Technology Conference, and this gives us a way to celebrate our announcements. So NVIDIA is a platform company now. It's not just an hardware company, but software and everything in between, like from chips, networking, software acceleration libraries, and this gives a good opportunity to announce what we have been working on. And CUDA is the backbone of it, and CUDA-X represent all the libraries that we have been accelerating for last 20 years. And for now, I think we have over 900 libraries and AI models that is powered and accelerated by CUDA. So this morning, the GTC keynote started by explaining what the scaling laws are, or these are the new 3 scaling laws, which is, it started with pre-training, which is the more you throw data, the bigger the model size, and the more compute you throw at it, the better model you get. Example is GPT-3, 3.5, 4, 4.5. The second scaling law is this post-training, where you try to fine-tune, distill, or try to do RLHF, where you take a foundation model and do more fine-tuning to get a better model. ChatGPT is one of them, where it was fine-tuned with RLHF method. And the most recent is the test time scaling, which is also known as chain of thought prompting, where the ChatGPT o1 reasoning models are based on. So they take a lot of compute, but the accuracy that they provide is unmatched. And I think the good analogy to test time or reasoning is they think every problem, they divide, the model divides the problem into step by step and then tries to solve it and then gives you the final output. Whereas the models like GPT 3.5, it is just first prompt, like they just throw the answer at you without thinking. So you can think of reasoning as kind of overthinking, but it works for the models, but in terms of humans, it doesn't work. So to solve the problem for test time scaling, or which is the inference, we announced NVIDIA Dynamo. So it is an open source software library which helps you deploy reasoning model at scale. And there are a ton of good features, which I can't go through because of the time limitation. But one of the features is disaggregated serving, so which basically separates the processing and generation phase of large language models on different GPUs for independent optimization. And with this, we have seen almost 30x performance boost for DeepSeek R1-based models. And it will also support all the open source backends like PyTorch, VLLM, SGL, and TensorRT. So the second announcement with regards to reasoning model was early this year, we released Llama Nemo-tron model. So Llama Nemo-tron is a subset of models, or models which were fine-tuned. So it is a fine-tuned variant of Llama using NVIDIA's own Nemo framework, which is used to build and fine-tune models. So earlier this year, we had released Llama Nemo-tron, which is a subvariance of Llama, but better. And this time, we have added reasoning capabilities to it. And we have released, or we are planning to announce and release 3 model sizes, which is Nano, which works best for PC and edge. The second one is Super, which is 49B variant of Llama. And the third one is Ultra, which is distilled from the 405B variant of model. And the good thing about this is this has a reasoning on and off toggle. So you can basically choose when you want to use reasoning mode that saves the compute for your specific application. And it is also 5x faster than all the other LLM models. And this specific Super, which is 49B, fits in a single H100 80 gig GPU. There's a detailed blog if you want to learn how this was trained. You can go at developer.nvidia.com/blog. There will be a blog in detail description about how that model was trained. Okay, let's move on to the agents. So 2023 was the year of models, 2024 was the year of RAG, and 2025 is next step, which is year of agents. And the way agents works is basically it is an autonomous application that plans, reasons, and acts by connecting the data, tools, and other LLM to tackle complex problem. And to this, solve this problem, we are announcing or introducing a new software library, which is open source, called Agent IQ, and it helps you efficiently connect and optimize team of agents. It works with all kinds of agent frameworks like Llama Index, Crew AI, and there's a small example that I can show. So you basically write an YAML file which has the function. Basically, these are tools then these are the LLM that you can set. So in this case, we are using NVIDIA NIM microservices, embedding models, and this is the workflow where you try to create the workflow of agent. And once this is set, you can run this YAML file, and then it executes the entire workflow. And once you do that, you basically get a run that executes the entire workflow. The deploy is basically you get a fast API server, and evaluate. You can basically use all the LLM ops tools available like Phoenix to evaluate how the entire pipeline is working. And now to the exciting part, which is new hardware that was announced. Starting with the data center GPU, we announced Blackwell Ultra. As a developer, what I see in this slide is just this 288 gigabyte high bandwidth memory, which basically helps you run large models on this GPU. So this basically connects 72 GPU into entire cluster, which is called GB300 NVL72. Next, we have DGX Spark. So it's a desktop AI supercomputer which has 128 gigabyte of unified memory, and it is based on Grace Blackwell architecture, which Grace is a CPU, Blackwell is a GPU architecture. And you can reserve them now by going at nvidia.com.
Sorry, quick question.
Yeah.
For the DGX Spark, what are the use cases that it supports? What would you recommend for this desktop?
Right. So I don't know specific use case. It should be on the website, but it's basically it's your go-to desktop computer accompanying your existing laptop. Yeah.
Does it work well for training workloads or mostly?
I think so. It should work with training workloads for smaller models like 8B. I'm not so sure about 49 or like the larger models because they need to fit on the memory first, and this has 128 gigs. Yeah. Okay.
Where you basically have a Linux operating system on, I guess, an ARM platform and can utilize the GPU just like a regular machine, so kind of like a Jetson on steroids.
Yes, yeah,
okay.
Yeah. Okay, so the next announcement was DGX Station. It's basically a supercomputer, desktop-style supercomputer, which has almost 784 gigabyte of GPU memory, and it would be available through our partner OEMs, and the availability is second half of this year. And last but not the least, Viviate is giving a talk tomorrow, and the talk is by Etienne, and it would be going over how to do GPU accelerated vector search. He would be showcasing how QVS, which is CUDA accelerated vector search, is integrated within Viviate to give your vector database GPU acceleration. So that was it. If you have any question regarding the announcement, come talk to me. I'll be happy to answer them. Yeah. Thank you.